Their mics are open so they can unmute to talk.
Yeah, you can as well unmute your mic and talk, please.
Good afternoon, Mr. Kaka.
Yeah, good afternoon.
And good afternoon to the house. Yeah, I was able to use the TPL data.
Okay.
To do the same thing that we did in the last class. I have it saved, I have the results saved in my file. So I don't know if there is any way I can share that with you.
Yeah, okay. So maybe you can drop it with the admin, then he's going to share it with me via maybe WhatsApp. And let me just show you guys how to, do you know how to create a GitHub account?
I already have a GitHub account. I have it set up some time ago. I think it was the admin, Mr. Justice, that mentioned it in one of our previous classes. If memory serves me right, I think that should be the cybersecurity classes then. And I had it created, and but I'm having trouble to search you up in GitHub. I wasn't in the last class. I noticed that you dropped your GitHub sign-in details for those people that were present in the class, and
yes,
all effort to get it from them has proved abortive. No one is ready to give it out. So I implore again if you can give it to us again today.
All right. All right. Yeah, that's amazing. I'm going to be sharing my GitHub account with you guys today. Please, if you do have your Jupyter notebook ready, you can as well upload it to your GitHub and then maybe share the link to the repo with me. Make it public, not private.
Oh,
and then
okay.
Yes, just upload the notebook to your GitHub. Yeah, you can do that by just maybe creating a repository, and then you can just drag and drop the file to the repo, and then maybe share the link with us.
All right, I'm going to do that.
All right, that's amazing. So please, next person, if you've done yours, please go ahead and share with us, please. Please, if you've done yours, just go ahead and share with us, please. By the way, let me just mute and let me go ahead and share my screen with you guys while I'm on that. Please do verify if my screen is visible. Please, someone should verify if my screen is visible, please.
Okay. I think it's visible. Let me check.
All right, Juliana.
100,000.
All right, that's amazing. Please go ahead and mute your mic, please, so that. Yeah. So please, Juliana says she has done. Okay. All right. So please, if you're done with your projects, let me just go ahead and show you guys how to upload it to GitHub. It's actually very easy. Let's say, for example, this is my home screen. Yeah, this is my home screen. This is the home screen. So I believe it's going to be the same for you guys. I believe everything is going to be the same for you guys. So just go to repository, click on repository, and this is going to take you to your repos. Then go ahead and click on, you can see we have, GitHub, Control-2. Let me see if I can illustrate. Sorry, I lost you guys for a minute. Actually, I had a GM call, so I had to go and divert all my calls. Let me just go ahead and share my screen again. Please do confirm if my screen is visible, please.
Yes, it's visible. It's
all right,
visible.
that's amazing. All right, okay. Just go ahead and let me just go back so that I show you guys how to maybe this should be the same with you guys. Just go ahead and click on repositories. This is going to open this repository for you guys. Then go ahead and you can see a new button on the top right. Just click on the new button. This is going to open this page for you guys. And just come here and repository name, give it something like IGTA underscore IGTA, something like that, IGTA underscore projects. Yeah, this is going to check the availability and maybe add a description. This is optional. So IGTA projects, repository, something like that. So please go ensure that it is public, because if it's set to private, it's not going to be visible by anyone except you. So just make it public, please. Just make it public. So, and you can as well add a README file. This is optional as well. So I'm just going to go ahead and click on add README, or just neglect it for now, because just add a README file, because you're going to be needing that maybe for description or to explain your repo, something like that. And then click on create. On the bottom right, you can see, just neglect the other options and click on create. So this is going to create your repo for you. As you can see, we have the repo now. It's IGTA project. And then there are many ways to add some files here. Just go ahead and click on this add. As you can see, there is add button. My illustration tool is not working. I don't know what's wrong with it. Maybe my computer needs a restart, but we don't have time to do that. So just click on this add file. As you can see, this add file button here, click on it. You can as well create a new file, and you can as well upload a new file. Just click on upload files. Just click on upload file. You can see drag files here to add them. If you like, you can drag and drop. For example, I can go ahead and open my file manager and then maybe reduce the window size, something like that. Just reduce the window size like this. And then let me see what I can add. Okay, I have these tips, data analysis and visualization. I can just click and then drag it, maybe drop it here, right? This is the simplest way to do that. This is the most simplest way to do that. So as you can see, if you go to the button, it shows that uploading one file. So this is going to upload your file. And there's another option to do that. Just click on choose file. This is going to open your file manager as well. And then go, maybe I have mine in downloads, and something like introduction to Python. And then I'm just going to go ahead and select, let's say, linear regression, which is our last week's notebook. I'm just going to go ahead and click on open. As you can see, it has uploaded. So you can write some commit changes here, something like added first assignment, something like that, just for you to track something like that. So I'm just going to go ahead and click on commit changes, bottom left, commit changes. So this is going to upload everything to your repo. As you can see, we already have the files here, linear regression, and then tips, data analysis, and visualization. So if I go ahead and click on the linear regression, this is GitHub has a built-in notebook reader. So this is going to just directly open the notebook for me. As you can see, this is what we did in our previous class. So I'm just going to click on this to go back. And how do you share this with us? How do you share this with me? So just click on the browser, the URL on the browser, select everything, Control C to copy, and then you can just paste it as well. You can just paste it anywhere you want. So whoever that has access to this link is going to take your visitor directly to this page. So I can be able to have access to this. Please do ensure that you make it public, because if it's not public, I cannot be able to access your files here. So I believe this is actually very simple. This is actually very simple. Okay, Jackson said he tried doing the assignment. He installed Seaborn, but the challenge he had was to open a new Jupyter notebook to start building the project. Okay. During the installation, you could not open a browser to start. You only run, okay, requirement satisfied. All right. See, okay, Jackson, that means that, okay, see, I've already shared a video with you guys. I believe it's, I don't know, maybe if it's available, because I don't have access to those videos. You can as well go and check the video on how to install Jupyter Notebook to your machine. If Jupyter Notebook is available on a machine and then you're having difficulty starting it up, I can just go ahead and show you guys, right? So secondly, if you want to have access to my repo for the machine learning project, let me see, let me just go ahead and share the repo with you guys because it's very amazing. Don't forget to drop a star, please. Let me check. Let me check. All right, let me just go back to my repo. Let me click on the repo. Let me just click on the repo and share the link with you guys. Yeah, ML for beginners. So I'm just going to go ahead and, as you can see, this is the main use of the README. You can, as you can see, this repo is well documented. So you can do the same thing for your repo as well. Please make sure that you document it. As you can see, machine learning and deep learning from beginner to advanced. It welcomes you guys, and then the repository contents. Even though yours might not be as nice as this, because this is a bit advanced. I use some advanced editing and the rest. So for you, it might just be a text without any fancy looking headers and the rest, without any emojis. You can just go ahead and write a very comprehensive description of your repository. You can do that by just clicking on this pen icon. Please pay attention to the mouse pointer, because my illustration tool is not working. Just click on this pencil. This is going to open the editor for you. And then you can just as well go and type whatever you want here. After you're done, you can just go ahead and click on this commit on the top right, as simple as that. So for me, I'm not committing anything. I'm just going to go ahead and click on cancel. I'm just going to go ahead and click on cancel. So this is going to cancel everything and then bring me back to the repo. So let me just copy the link and share with you guys so that we can go ahead and start our today's class. So I've copied the link, and then I'm just going to go ahead and drop it in the chat section. So if you click on this link, it's going to take you directly to this repo. You can have access to all the notebooks and everything. Please do ensure that you're reading this. If you just copy the linear regression challenges and then send it to me as your classwork, I'm going to know, because it's my work. So please use it as an inspiration or use it as a guide to do your assignments, please. Do not just copy, because I believe students are fond of doing that. Do not just copy and paste the same notebook for me, please. I'm gonna know. So just use it as a guide, and then to do your assignments and just drop it, right? So without any further delay, let me just check the chat section. See, Juliana, you're not seeing repository on your Jupyter notebook. Honestly speaking, we are not using Jupyter. We are not using, it's not a Jupyter notebook. Just go to github.com, right? Just go to github.com and create an account, right? github.com, right? Go to github.com and create an account, please, right? Create an account. It's going to show create an account for you. For me, I'm already logged in, so it's not going to show create an account, please, right? It's not in the Jupyter notebook. This is GitHub, actually. This is GitHub. So just go to GitHub, use your email and password to create an account, and then go to your profile and then click on repo, right? Please pay attention, right? And then you can use, maybe you can use this video as a guide to upload your files. I believe it's recorded, so you can just go back and front until you have your notebooks uploaded to your GitHub, and then just go ahead and share the link with us. Someone said he's having difficulty opening the notebook. It's very simple actually. Let's say for example, I have this folder here, which is Introduction to Python, which is what we have been doing so far. So come to this address bar of your file manager, then type cmd. If you type cmd and press enter, this is going to open the command prompt in the current working directory, right? So just go ahead and run Jupyter, Jupyter, then space, then notebook. If you have Jupyter installed, this is going to work. If you just click on enter, it's going to open the browser for you. If you don't have Jupyter installed, there's a video that I recorded for you guys last month. Just go ahead and refer to that video, and then it's going to guide you on how to install Jupyter on your machine. By now, I believe most of you. So this is going to take you to this page. This is going to take you to a page like this. As you can see, I have a fresh notebook here. So I'm just going to go ahead and click on. I'm just going to go ahead and maybe click on maybe new. As you can see, we have a new here. Please pay attention to the mouse pointer because I don't have my illustration tool today. So click on new and then click Python 3 as your kernel. Just click on this Python 3. New Python 3. Give it maybe a minute or two to load. This is going to open a fresh notebook for you guys. Okay. Oluseun is sharing a picture. Okay, let me just go ahead and look at that picture. What are you trying to send? Okay, Oluseun, you got this error message. Okay. Let me go ahead and take a look at your error message. Please, you guys should be practicing more because we're doing advanced, because we're doing some advanced stuff now. Okay, Oluseun, just remove the .2f, please. Just remove the .2f in your mean squared error, right? If you take a look at your mean squared error, there is a .2f. Just go ahead and remove the colon and the .2f and leave it like that. I believe it's gonna work. Just remove the, do not round your, for some reason, it's been giving us error last week and removing the .2f cleared the error. So please do the same. Just go ahead and remove the .2f, the colon and the .2f. Just leave your variables in the curly braces and it's gonna work, right? So we have a fresh notebook here. I'm just gonna go ahead and rename our notebook to Logistic Regression, because this is what we are supposed to do today, Logistic Regression. Beautiful. So we have our notebook named. So before I proceed further, let me just go to my whiteboard and then do some explanation for you guys before we write some coding. So please, do you have any question pertaining to our last class? If you don't have any question, we can just go ahead and begin our logistic regression. Please, if you have any question pertaining to the last class, go ahead and ask. And then if you don't have, please, I'm just gonna jump right into logistic regression. As in our last class, we did, let me change the, so in our last class, we did, let me increase the thickness. In our last class, we did linear regression. Linear regression. This thickness is too much. So in our last class, we did linear regression. But if you take a look at the linear regression we did, is a single variable linear regression, right? Where we predicted the prices, of a house, right? Using a single feature, right? Using just a single feature, which is the size of the house, right? Using the size of the house as a feature, we were able to predict the price. right? So I gave you guys an assignment as well to go and browse, because it's literally available. Maybe go to Kaggle or something like that. Go and browse. Please, I want you guys to do a multi, right? Use multiple features, right? Multiple features. For example, something like multiple features, right? Multiple features like, for example, the size, comma, the location of the house, right? The location of the house, comma, maybe the number of bedrooms, right? The number of bedrooms, and maybe whether it has, I don't know, maybe whether it has a balcony or something like that, right? Just go, and then based on these features, which is a capital X, right? Based on these features, I want you to predict the Y, which is the price. So please go ahead, and I don't know, maybe if some of you have done that already, right? I don't know, maybe if some of you have done that already, but this is what we did last week. We did the single variable linear regression. So today we're going to be doing logistic regression. So before we proceed, let me just go ahead and explain something to you guys, which is very crucial. In logistic regression, please, if you're not seeing the whiteboard clearly, go ahead and tell me so that I can increase the font size. We have logistic regression. I'm just going to write R because we're out of space, honestly. And then we have linear regression. So most of my students ask me, what is the difference between linear regression and logistic regression, and when do you use linear regression, and when to use logistic regression? It's actually very simple. For linear regression, as the name implies, it's only when you have a linear, only when you have a continuous number, right? Continuous number like what? Like, for example, we have weather, right? Weather. Let's say you have weather for maybe 10 years, right? 10 years. And then maybe based on these weather patterns, you want to predict the weather for maybe tomorrow or next tomorrow or for next month or for next year, right? So this is a continuous value, right? This is continuous value, and it's numerical, right? Pay attention, it's numerical and it's a continuous value, right? Second thing is, like, for example, a stock price. A stock price, we believe a stock price is a continuous value. It always changes and it's linear, it continues, right? It either goes up or comes down, right? So maybe based on historical stock prices, you want to predict maybe the stock prices of maybe tomorrow or something like that. So this one you use a linear regression, right? And for example, let's say you want to predict the price of houses, right? Price of houses. It's a continuous value, right? It's a continuous value. It either goes up or down, right? So you want to predict the price of houses, maybe based on what? Maybe based on the features. I don't have to go deep into that. Maybe size. We've already done that. Size, and then maybe location and the rest, right? Okay, there are comments. Please, Joseph, this is gonna slow us down a little bit. Maybe after this class, I'm gonna be attending to your errors, please, because there's no enough time. Honestly, we don't have enough time. Actually. So, see, please close your bracket. Close your bracket, right? Go ahead and close your bracket. In just 1 second, I've seen your error already. Please just close your bracket. As simple as that. X trend, comma, X test, Y trend, comma, Y test is equals to trend test split, right? Open your bracket, X, comma, Y, right? After the random state is equals to 42, please go ahead and close your bracket. This is a very minor error that you should be able to fix by now, because we're doing advanced machine learning, right? And this is a very common programming error. Just close your bracket and close your bracket and it's going to work, right? Just close your bracket, it's going to work. So without any further ado, please, let's continue. And for the logistic regression, which we're going to be doing today, when do you use a logistic regression? Let me expand this a little bit. It's very simple, actually, if you pay attention. It's very, very simple. is when you want to do some classification problems. For example, when you're working with categorical values, for this is a continuous value, right? For linear regression is a continuous value, continuous. It changes over time. And for logistic regression, which we're going to be doing today, it's categorical. For the sake of beginners, categorical is either maybe yes or no, something like that. Please, it's very simple. It's when you want to work with categories, right? Category is not a linear, it's not a continuous number. So you cannot use linear regression to solve such a problem. You use what? A logistic regression. So for example, let's say for instance, you want to predict maybe, okay, I'm not into election, but let me just use election for that. So let's say you want to predict, let's say you have PDP, comma, maybe you have APC, comma, I don't know, I'm not a politician. Honestly, I'm just going to be using these two parties, right? Or AFGA or something like that. And then maybe based on these classes, you want to predict which party is going to win, right? Which party is it? Is it PDP? Is it APC or some of the parties, right? Up to party N, right? So which party is going to win? As you can see, this result is a category. We have how many categories? We have 1 category, 2 category, and up to category N. So based on these categories, you want to choose a single category that you think is going to win. So when you have a problem like this, you can use a logistic regression to solve it, right? And then what again? For example, I made mention of Google spam detection in our last class. For example, let's say when you want to do email classification, which is a simple logistic regression problem, email classification problem, right? You want to classify email as maybe spam, right? Spam or not spam. For the sake of beginners, a spammy email is all those emails that you receive from companies that you have zero idea of, telling you to click on this to get 1 million, click on that to register for that, all those scammers, right? All those spam emails that you get in your spam folder. So you want to categorize email as a spam or not spam. You see, this is a binary classification. You have only 2 classifications. When you only have 2 classifications, it's called what? A binary classification, which is just what? Maybe a yes or no, or spam or not spam. When you have 2 classes, it's called a binary classification. And when you have multiple classes, right? When you have multiple classes, it's called a multiple classification, right? As the name implies. So maybe spam or not spam, simple as that. Or another problem is maybe based on customers' historical data, you want to predict whether your customers will be able to will buy your products, right, or not. As simple as that. Maybe your customer will buy products or not. So you're going to have maybe some features like maybe the customer's age, right? Maybe the customer's gender, right? Maybe the customers has added the product to cart or to a wish list, something like that, right? For all the e-commerce data analysts, right? So based on that, you want to predict whether the customer is going to buy or not buy. You see, this is a binary classification. So whenever you have a problem like this and you want to make predictions, right? Maybe you're in the sales department, maybe you're in politics, right? Whatever your situation is, whatever your problem is, if it's a classification problem, you have to use what? A logistic regression to do that. So with that out of the way, let's just go ahead and continue, please. Let me shrink that a bit and push it up. Let me shrink that a bit and push it up. So we have some classification type. Let me show you guys. We have some classification types, right? I've already said that, but let me just do it again. Classification types. Classification types. Right? Please pay attention to this. These are basic things that you have to know. We have binary. which is what? Which is basically yes or no. And then for the we have what? We have multiple classification or a multi-class, right? We have multi-class, right? Or classification, anything, just anyhow, right? For example, you want to maybe classify maybe some flowers. We have iris data sets, right? Or maybe let's go to politics a little bit. Maybe PDP, APC. I don't know. Maybe is there, what is it called, Afghan or what? I don't know. Actually, I don't do politics. Sorry for that. So when you have multiple classification, right? This is called a multi-class or multiple classification problem. And when you have maybe spam or not spam, e.g. spam or not spam, this called a what? This called a what? A binary classification. So if I were you, I'll be taking notes, please. I'll be taking notes because this is very crucial to know, please. So the next thing that I want to show you guys is for example, why do we use logistic regression? Why do we even use logistic regression? So let me go ahead and make some illustration for you guys. Please pay attention here because this is very crucial. Pay attention. So for example, let's say we have a chart like this. We all know that logistic regression in our last class use what? Y is equals to mx plus b, right? Mx plus b to draw the best fit line to make predictions. Please, if you haven't checked that already, I encourage you guys to go and browse this. Maybe go to it's fun and learn this equation. It's very simple and it's very fun, right? So y is equals to mx plus b. So it's going to plot something less or not by, right? You're going to plot something like this. Let's say you have a graph like this, where you have your x, maybe, and your y, right? On this x, let's say you have 0, and you have maybe 0.5, and then maybe you have 1, right? And for example, maybe here let's say you're using the age of the customers to determine whether they are going to buy or not buy. Let's say you're selling some fancy iPhones, and then you want to determine whether the customer is going to buy or not buy based on their ages. We know that all people are not fond of using all these fancy gadgets or something like that. So for example, if you plot your, let's say you have 20, 30 years, 40 years, 50, 60, right? 70 years, and then maybe 80. Or let's give it a 90. Let's give it a 90. So for example, and let's say you've already plotted, see, 0 means not by. We all know that. I don't have to explain this, right? 0 means not by, right? And then anything above maybe 0.5 to 1, right? It's by, right? So for example, for the age of 20, you have something like let's say you have something like this. Let's say for 30 years, let's say you have some data points here. After plotting your scatter plot, let's say you have some, let's just give some random, we're just doing things randomly here, right? Let's just give you some random values, some random points, please. We're just doing things randomly here. We don't care about precision. We just want to grasp the concept, right? Let's say we have some data points like this. So in linear regression, what it does, it draws a best fit line, right? So for example, let's say we draw our best fit line from here, something like this. Wow, that's straight. This is basically literally assisted. So let's say we have our best fit line like this, right? So and if you take a look at these data points, so we're going to be using what? Okay, I should have explained this before I had this. Logistic regression uses what? It uses a function called a sigmoid function. Sigmoid function, right? It uses a sigmoid function. The goal of this function is to convert a number into what? Between 0 and 1. between 0 and 1, as simple as that. So if you give it, don't worry, we're going to be doing that later in the coding section. So if you give it something like 1 million, it's going to give 1, right? It's going to output 1, right? And you give it something like anything below 0, right? Anything below 0 is going to give 0, as simple as that. So it converts your numbers into probabilities, right? 0 or 1. So that's why we use it in logistic regression. So for example, if you take a look at this linear regression, actually there's a problem, right? There's a problem. If we cannot use this linear regression to categorize our customers. For example, if you take a look at this straight line, and let's say we divide our data like this is what we call a decision threshold, right? Anything from 0.5. This is what we call a decision threshold, right? In logistic regression, we care about from 0.5 and above. Anything below that is a no, and anything above that is a yes, right? For example, let me just use this to illustrate. Anything here is a no, right? That means will not buy, and anything here on the right side is a yes. So, but there are some data points that are left here. So, for example, if you take a look at this is going to work well for little data set. If your data set is little, you can see that these numbers, these people right here are in the yes zone, right? They are in the yes zone. So this is going to work for a little data set, right? And anything below here, we know that it's below 0.5. They are in the no zone. So this classification problem can be handled by a linear regression model. But let me show you guys, there's going to be a problem when the data set is small, right? It's larger. So this can be solved by a linear regression model. It's going to fit the baseline, and then it's going to calculate the error between the data points to the best fit line, and it's going to perfectly categorize your data for you. So, but let me show you something. There's going to be a problem when you have a larger data set, right? For example, let's our graph again. Let's say we have something like this, and we have our 1, we have our 0.5, and then our 0, right? And for the ages, let's say we have 20, we have
Yeah, MK, we can hear you. I don't know if you're speaking. Kindly check your microphone. We lost your audio.
Am I audible now, please? Please do verify if I'm audible.
Yes, you are audible now.
Yeah, you are good now.
All right, that's amazing. If I'm audible, that's cool. We can go ahead and continue, please. So the problem with this is this is not able to capture all our data points. That's the problem with linear regression model. Whenever you're performing a categorical classification like that, it doesn't cover everything, right? But let me just go ahead. As you can see, what I was saying is for example, if your data set is larger, there are some data points that are skipped, that are not covered by the best fit line. If you take a look at this data, it's not covered by the best fit line. And let's say you have some data points here, right? It's not covered by the best fit line, right? It's actually not touching. It's not touching. So this is where you use what? Where you use a logistic regression model to solve your problem. So let me draw them side by side so that you see the difference. Okay, let's try to do a sigmoid function. Don't worry, I'm going to show you guys the equation just in a minute. So what a sigmoid function does is that, for example, let's draw the same data sets here. Let's say, all right. Let's say you have your data set like this, and let's say you have your 1, let's say you have your 0.5, and then let's say you have your 0, right? And maybe let's say you have 20 for the ages, 30, 40, 50, 60, and 70. Yeah, let's leave it like that. And then let's say you have some data points like this. Let's say you have some random data points like this, right? Just some random up to, let's extend the data set to make it larger. Let's say it's very large. Let's say 80, 90. Let's take you up to 100 to make the data set larger, right? So let's extend it like this. So for example, let's say 80, 90, your data set is very large, right? So, okay, let me just try and draw a linear, a best fit line like this. You see, this has left some data points out, right? As you can see, it has left some data points out. It did not include them, right? So how do you fix that? That is when a sigmoid function comes into play, right? So what a sigmoid function does is it squashes all your outputs and then it makes them a probability between 0 and 1. It draws something like this. So that includes everything. I don't know, maybe this is not a perfect X. You see, a sigmoid function, by me looking at this, we know that everything is included, right? Everything is literally included. So if you go ahead and draw your decision line from 0.5, the reason why we're drawing this, most beginners ask me, why are we drawing the decision line on 0.5? See, anything below this 0.5 is considered as no or 0, right? If it's maybe a spam or not spam email, it's maybe it's spam, right? And anything above, sorry, it's not spam. Anything above 0.5 to 1 is considered as a yes category, or 1, or just choose, you can choose any category that you want, right? Yes category, 1, or spam, something like that, right? And it has included everything. If you take a look at it, it has included all the data points. It squashes them into probability between is either 0 or 1, right? So let me just go ahead and show you guys some explanation. And how does it do that? It actually takes this. We all know that this line is the y is equals to mx plus b, right? Is the best fit line. Please, if you haven't done that, go ahead and learn how to draw this line, and everything is going to be so easy for you, right? So it's this line, and then it ensures that it curves the line and ensures that it's touching all the data points, right? So how does it do that? It's actually very simple. Let me show you guys the equation on how it does that. So for example, let's say we have the formula for the sigmoid function is actually sigmoid like this, sigmoid z, which is equals to 1. Please, for people that hate mathematics, please don't be scared. This is actually very simple equation. 1 plus e raised to the power of minus z. This z is the same with this place. Pay attention. Sigmoid is equals to 1 divided by 1 plus e raised to the power of minus z. Any value you give to this function, it is either going to be converted into 0 or 1. Any value. If you give it a 1 billion, it's going to convert the 1 billion to either 0 or 1. If that value is above 1, above 0, it's going to give 1. If that value is below 0, it's going to be 0. So it gives it turns your number into a probability. 1 high probability, and then we know 0, right? I don't have to explain the 0. So let's say, for example, we have y, our best fit line, which is y is equals to mx plus b, from our what? From our linear regression line. How does it curve that line to ensure that all data points are included? Let's say, for example, let's have a dummy data. Let's say, for example, let's give it some dummy values, please. Let's give it some dummy values. Let's say, for example, our m, which is this. Let's say our m is 2. Let's give it some simple values. And sorry, m is equals to 2. And let's say our b, is equals to 1 to make things simple so that you guys will understand, right? And then let's say, for example, our x, this x, let's say is equals to 1. So how do we solve that? So the sigmoid function is going to be something like sigmoid function, which is z, which is something like this, is equals to what? Let's calculate the y is equals to mx plus b first. So what is m? We know that m is 2. Please pay attention here. It's very simple. M is 2, right? It says mx, right? Whenever you see m and x, it means you multiply them. That's very basic mathematics. So what is our x? Our x is 1, as you can see here, 1, right? So plus, what is our b? As you can see, our b is 1 as well. So our b is 1. So 2 times 1. 2 times 1 is 2, right? Plus 1 is equals to 3. So our y, sorry, this is going to be the y. Our y is equals to what? Y is equals to mx plus b, right? Our y is equals to 3. As simple as that. So let's say this is the value that we obtain in this best fit line for a single data point. It calculates it for each and every data point in a linear regression. Let's say for the first data point, we have what? We have 3, right? So how do we convert that to a probability? How does the sigmoid function convert this to a probability, a number between 0 and 1? It's actually simple. Let's say sigmoid function z is equals to what? The formula is 1 divided by 1 plus e raised to the power of minus z, right? So and this z is what? Is nothing but the mx plus b. That's the value that we got from the linear regression. This z is nothing but what? The mx plus b. We are just converting it to a probability, right? So, and we have already calculated our mx plus b, which is 3, right? So this is the same as 1 divided by 1 plus. This e is called an Euler number, please. Euler's number. What is an Euler's number? Is I believe Euler's number is 2.718. This e. Many people ask me, what is this e? It's actually an Euler's number, Euler. So, same thing as, for example, for pi, we know that the value of pi is a constant, right? Is 3.14. So an Euler's constant is what? Is 2.718. So E is equals to 2.718. That's a constant number. So 2.718 raised to the power of what? The equation says raised to the power of what? Minus mx plus b, right? And our mx plus b is 3. So raised to the power of minus 3. So that you raise that to the power of minus then the value of mx plus b. So if you punch this in a calculator, I believe it's going to give you something like 0.95 or something like that. 1 plus 718 raised to the power of 3. Then you divide that by 1. So your sigmoid value is going to be 0.95 or 2, something like that. You see, our mx plus b, which was initially 3, has now been converted to what? To 0, right? 0.95, which is almost what? Which is almost 1, which is almost 1. We know that 9 is almost 1, right? Which is almost 1. So let me just go ahead and show you guys. So let's jump into Python. So that I'm going to show you guys how actually this is done in Python. If you're not fond of doing mathematics, it's actually very simple. So let's just go into our code editor to write a simple program that is going to do that. Where is the code editor? I believe everything is running. Beautiful. So if you want to follow along, please, if you want to follow along, it's actually, I'm just going to be a little bit fast because of the time constraint. So we all know that, let's go back to the whiteboard and check, please. The formula for the Sigmoid function is what? It says 1 divided by 1 plus e raised to the power of minus what? Minus z, right? So let's go ahead and let me just write a simple algorithm that is going to do that, as simple as that. So I'm just going to import numpy as what? As np. For the sake of the beginners, numpy is just a numerical Python library that is used for doing some scientific calculations, as simple as that. And then I'm just going to import, matplotlib because I want you guys to see the visualization as well. Matplotlib.pyplot as plt, right? Let me just make a print statement below to see if it's successful. Successfully loaded. Yeah, it's loaded successfully, right? So let's define a function. How do you write a function? You just start from the word def. You're defining a function in Python. I believe we've already done that. I don't know, I forgot. So define sigmoid. So I define a function sigmoid. It accepts a parameter called what? Let me go back to the whiteboard. It accepts a parameter called what? Z, right? So let's go back to the programming. It accepts a parameter called Z, and then I'm going to close my bracket, right? So the formula says return 1 divided by, right? 1 plus, right? You can get the Euler's number inside this numpy library like this. We have this numpy library. So np.exp, open bracket. Let's check the formula again, please. 1 divided by 1 plus e raised to the power of minus 2, minus z, right? E raised to the power of minus z. That's the formula. So np.exp raised to the power of what? Minus z, which is this parameter that we received, which is literally the number. So believe it or not, we are already done with the function. We are already done, right? So let me verify. Let me just go ahead and run this cell. There's a problem, okay? Incomplete input, all right? Yeah, I believe now it's complete. Believe it or not, that's the beauty of programming. We are done with the Sigmoid function. So let's give it a number. Let's say print Sigmoid Let's give it maybe 1,000 and see whether it will convert it to 1. As you can see, we just gave it 1,000 and then it converted it to a probability, right? Now it's 1,000 is 1. Because of what? Because it's a positive number. So let's give it maybe 1 billion. Sigmoid, 1 billion, something like that. Let's go crazy with the zeros. You see, it's 1. We're getting 1, right? So let me give it a negative number, please. Let me give it a negative number. Print sigmoid, something like minus. Let's give it sigmoid 0. You see, anything, if you give it a 0, it's going to return 0.5, right? If you give it 0, it's going to return what? It's going to return 0.5. So anything below 0, anything below this 0, let's give it something that is below 0, which is minus 3. You see, minus 3 is converted to what? Minus 3 converted to 0. So sorry, I had to divert my calls because people have been calling me crazily. Please do verify if my mic is audible. Please do verify if my mic is audible, please. All right, Oluseun, thank you so much for that. Let me connect. Sorry, just give me a second. Let me connect my laptop to the power source. I forgot. It's actually warning me that the battery is low. Yeah, that's cool. Laptop is connected to the power source now. So let's continue. So how do you visualize this? I know by now, most of you are asking maybe, okay, we believe there is a Sigmoid function, but how does it draw the curve, right? How does it draw the curve? So let me just go ahead and write some program for that. So let's say, for example, we have our inputs. Let me go back to the whiteboard and show that. I want us to be on the same page, please. I want us to understand this thing as easily as possible. So if you take a look at these data points, we have data points from what? From 20 up to 90, right? But the Sigmoid function, if a number is below 0, right? If a number is below 0, it returns a negative. If a number is negative, it returns 0, right? And if a number is positive, it returns 1. So let's simulate. Let's have a number. Let's have an input that is between, that consists of a negative number and a positive number as well. That is sequential from the lowest to the highest, so that we can simulate the curve. So you can use NumPy to generate numbers that are between, let's say, -5 to 100 or something like that, right? So let me have a function z. Let me have a variable z, because that's going to be my input. Z is equals to mp.linespace, right? From, let's say I want a number from -10, right? To, I want the gap to be in 1010, and then to up to 100, right? This is actually very simple. I want np.linespace. I want a number between -10 to 100, and then the gap between them should be 10. That's basically what this function is doing. This, yeah. So if I go ahead and print, let's actually print it so that we see the numbers. Print z. Okay, we are having an error. What's the error? Okay. Okay. Sorry. It's actually a linspace. That's my mistake, please. Yeah, beautiful. So you see, we have numbers. We have numbers beginning from -10, right? -8, -7, -6, -5. Okay, let me just make it 200. So let's just make it big, please. You see, up to 100, right? That's too much, but no problem. We can work with that, right? So how do we do a Sigmoid function with that? So okay, let's give this value to a Sigmoid function and see. Let's say I have okay, let me just be commenting my code. Apply Sigmoid function to numbers, right? So I'm going to define a variable called sig, and then I'm going to call the Sigmoid function, this function that I wrote here, right? This function here. So Sigmoid, and then I'm just going to pass the z, the numbers that I generated, right? Sorry, I made a mistake here. There should be an equal sign here, which is an assignment operator, right? So if we go ahead and print sig, we have all these numbers, but if you pay attention, they are converted to probabilities, right? But it's not going to be visible here. We have to use the graph to visualize everything. So how do we graph? How do you plot this? It's actually very simple to plot. plt.figure size. Let's create a canvas of with fixed size of let's say for example 10 by 6, 10 by 6. This is basically the size of the graph that I want to design. It's very simple actually, right? Let me put this in a bracket. Fixed size is a tuple, so it has to be in a bracket. So plt plot, right? I want to plot the z, which is this, right, on the x-axis, and then on the y-axis. If you remember our visualization class, whenever you say plt.plot, the first value is your x-axis, and then the second value is your y-axis, right? And then on the y-axis, I want the sigmoid value. On the x-axis, I want the real values, which is this. And then on the y-axis, I want the sigmoid values, which is this, the number that we converted into sigmoid, right? So, comma, the labels should be sigmoid, something like that. Sigmoid z. Please, your label should always be descriptive. And then I want the color to be maybe red or blue. Let's just go with blue, right? So let me just go ahead and maybe add a title, plt.title, something like sigmoid function, the classification zone, something like that. And then maybe I want the x label to be z, plt.x label. I want it to be just z, because it's the z that we are printing on the x label. So let it be just z. And then plt.y label, I want it to be sigmoid, because on the y-axis is actually the value that is converted to sigmoid of z, something like that. Right? So, and then I want to add a grid, plt.grid, so that you can be able to see everything. I want to add grid to it. Plt.grid is going to be true. And then plt, I want to add a legend as well. plt.legend, and then finally plt.show. Right? We're having an errors, which is, it's normal. We can fix our errors. It's actually cool that we are seeing our errors. Plt.plot z, sig. All right. Why are we having errors? Why are we having errors? Okay, plt.plot. All right, let's go back and check where are we having the errors, please. Let's check our code. From -10 to 200, which is correct. We've already tested the sigmoid, which is correct. And Z is equals to NP dot linspace -10 to 200, which is correct. When again, we define a variable called sig, and then we call the sigmoid function, and then we pass the Z, the numbers that we created. Yeah, which is also correct. So we created a figure, plt.figure, matplotlib as plt, which is correct. What is happening? plt.plot, and then we apply plt.plot, we're given the Z value, which is correct. And then we're given the sig as the second parameter, which is also correct. The labels is sigmoid, which is correct. Okay, then where are we having the errors? Let me run that again. Okay, plt plot ask float. Let's scroll down and see. Oh, it has actually plotted, but got an unexpected argument. Okay, got an unexpected argument called. Okay, sorry, my mistake. It's actually label, not labels, please. Label. It's a label. You see, that's the beauty of programming. You actually see me making this mistake in real time, and then you can be able to see how I'm fixing my errors, right? So whenever you have an error, let me just simulate the error one more time, please, so that you guys will understand. Let me just add the S intentionally, right? What you have to do is, I don't know, maybe as a beginner, it's going to be a bit difficult to spot your errors, but if you scroll down to your errors, right? If you check the last part of your errors, you see attribute error, right? Python is so cool that it highlights everything for us. You see attribute error, line 2d.set got an unexpected argument called labels. That means okay, it's showing me, okay, Juliana is telling you that sigmoid is not defined. How can you resolve it? See, please make sure that whenever make sure that when you write this function, run it. Define the function, right? You have to define the function. Define sigmoid, right? Define sigmoid, open your bracket, and then pass Z as the number that the function accepts, right? Put your colon and then press enter. Then what you're returning is just the formula of the equation. 1 divided by open bracket, 1 plus np.exponential -z. After you define this function, please run the function. It's either you press shift plus enter, or click on this play button. Ensure that this function is it has been executed, as simple as that. So I'm just going to go ahead and correct these labels to label. And then I'm just going to go ahead and press enter. Wow, that's beautiful. So please, let's pay a close attention to this beautiful sigmoid function. As you can see, if you pay a close attention to this curve, right, anything below 0, if you take a look at it, from the 0, it started going up, right? And according to the sigmoid function, it says that anything below 0, 0 is considered as 0.5. If you take a look at here, we printed, where is it? Okay, let me just go ahead and do that again, please. If you pay attention, these things are actually simple. So let's print a sigmoid of 0, right? Print sigmoid 0, right? You see, sigmoid 0 is 0.5, right? So let's go back to the graph. Oh my God, I wish my illustration tool is working right now. If you take a look, we have 0 in the middle, right? So sigmoid 0, let's pull this line up. If you come up here, you can all see that we have 0, we have 0.2, we have 0.4. In between 0.4 and 0.6, there is a 0.5. And if you pay close attention, we can see that sigmoid 0 is actually what? 0.5. And anything above 0, let's say, for example, as you can see, 2.5. 2.5 is almost 2.5 is almost 0. 0. Maybe 9 or something like that. You see, anything above that, 5.0 is 1, right? 7.5, as you can see, is 1, right? And then 10 is 1. So if you continue adding this number, it's going to be 1. Let me just add some things so that let's make this a little bit advanced so that you guys should understand what is actually happening here, right? So let me just go ahead and add some few things. PLT, let me add some line to make it visually appealing. What do I add? Let me just add some axis to it. PLT.AX horizontal line, right, on the x-axis. I want to add line on the 0.5 so that you can see a line drawn on the 0.5, comma, and then I want the color of the line to be gray, and then I want the line style to be something like dash dash, right? And then I want the label to be the threshold, because Sigmoid function has a threshold from 0.5 above is 1. Anything below 0. Anything below that is considered as 0. So I want the threshold. I want to add a label that is called a threshold 0.5, right? And then I'm just going to go ahead and close my bracket, and then I'm just going to do that to the horizontal line. PLT.AX. I want a vertical line that is going to begin on 0 on this line. Since my illustration tool is not working, I'm just going to draw it programmatically. 0, on top of 0, I want the color to be a red line. And then I want the label. I want the line style. I want the line style to be dash dash so that it's easily visible. And then I want the label to be something like Z is equals to 0. Z is equals to 0, something like that. Yeah, I believe that's beautiful. And let me add some text to the threshold, right? But let me see if this is working. Yeah, beautiful. As you can see, we already have a line, right? We already have a line. So from 0 and above, anything on the right-hand side is a yes, or is a spam or not spam, or should buy or should not buy with a very high probability, right? And anything on the left-hand side is a no, and numerically is considered as 0. So let me just add that. Let me just add that so that everything is set, right? Let me just add that since my illustration tool is not working. PLT.text. We can actually add text to our charts. So I want it to be around. Okay, let me just write the text here. Around -6. I want to write yes. And then around maybe around 4, something like this, around here, around number 4, I want to write yes, right? So the text accepts the location. So the location is going to be from -6 to 0.6. And then I want to write the text no, which is also known as 0, right? I want the font size to be 12. And then I want the color to be something like maybe that way, right? And secondly, I want to add text on the x-axis. Sorry, on the right, I want my text to be on number 4. If you take a look at this, number 4 is between 2.5 and 5. Here is number 4, right? So the location, the coordinate to that is 4. From 4 to, on the y-axis is going to be straight here. From 4, and on the y-axis, I want it to be on top of 0.6, comma, the text that I want to add should be yes. And yes is actually considered as 1, right? Comma, I want the font size to be 12 as well. And then I want the color to be, let's say something like green, because green is for yes, right? So if I go ahead and run this, wow, this is so professional, right? So if you take a look at this, now we have already programmed our illustration tool. So anything from the left-hand side of the Sigmoid function is a no. and anything on the right-hand side is a yes and is considered as 1. Now you see the beauty of using the Sigmoid function, right? Now you see the beauty of using this Sigmoid function. I believe by now you guys are already familiar. Don't worry, I'm going to be sharing this code with you guys. It's a bit advanced because we are doing advanced analytics, but it's actually, my codes are simple. Honestly speaking, my codes are simple, right? If you take a look at this Sigmoid function, we just created it using maybe a single line, right? And then we just called the function, we just created a number between 10 to minus 10 up to what? Up to 10, right? Using this line. And then what do? We converted this number to probabilities between 0 and 1, right? And then we just plotted everything here. We plotted the real numbers, which is on the z-axis, against the sigmoid values. So as you can see, we have the real numbers, which is minus 10 to 10. And then we have the sigmoid values on the y-axis, which is from 0, 0.2, 0.4, 0.6, 0.8, and so on. And we drew this curve line on the graph, as simple as that. So since now we already know Sigmoid functions converts our result to probabilistic and it's a value between 0 and 1, how do we actually use that to build a model? How do we use that in our logistic regression, right? How do we use that? See, you can use this yes or no to perform any categories, any categorical problem, right? Okay, Juliana, I'm glad that you have gotten it. So let's just go ahead and build our linear regression model, which is actually very simple. So for the sake of this class, I'm going to be using a data set that is already available for us, which is the Titanic data set. I don't know, maybe let me see my browser. Please, you guys should pay attention because this is actually fun to do. Titanic data set. The reason why I'm using this data set because it's already readily available. I don't have to share it with you guys, right? This is the Titanic data set, right? If you pay close attention to it, it's a data set that shows either a passenger survived or a passenger did not survive, right? As you can see, we have the passenger ID, we have either the passenger survived, the class of the passengers, the age of the passengers, the SIP, the patch, and the fare, which is just the price paid, right? So based on these values, we can be able to make predictions. We can be able to predict either a passenger survived or passenger did not survive. So please go ahead and tell me on the chat section, how many categories do we have? What type of classification is that? Let me see who can be able to guess. We want to predict either a passenger survived or passenger did not survive. So please tell me on the comment section, what type of classification is that? Based on the classification categories that we offer. Please, what type of classification is that? It's even on the board here. What type of classification is that? Survived or not survived? Very good. It's binary classification. Why? Please, okay, it's binary. Okay, it's categorical. It's categorical. But what type of category is that? What type of category? Is it a multi-class or is it a binary class? And if you choose binary, why do you think it's binary? Why do you think it's binary? Survived or not survived? Very good. Olua, Olumuyiwa is correct because we have two items. It's a yes or no. Ishola, you're right. Ishola, you're correct. It's a yes or no. Okay. Wait again. Please do again. Okay. Paul, a yes or no. You're correct. Paul, you're very correct. It's a yes or no problem. And see, and the Sigmoid function is going to help us categorize this, right? Because 0 means no, based on the algorithm that we created so far. 0 means no, right? And sorry, 0 means no. The Sigmoid function is going to squash our output to either 0 or 1. 0 means what? Did not survive, and then 1 means survived, right? So let me just go ahead and do that. Let's convert our code to a markdown. Let's do that as quickly as possible because of time constraint, please. Let's convert this to a markdown. Titanic dataset, right? The Titanic dataset. So for the sake of you guys, I'm going to be doing some exploratory data analysis to refresh our our skills, and then maybe you can continue, right? So how do we import the data set, right? So before we do that, we're going to be importing pandas. Why are we importing pandas? Import pandas as PD. Please, is it visible? Is the text large? Let me just make it a bit larger, right? So import pandas as PD. I'm going to be importing Seaborn as SNS. And then I'm going to be importing, I've already imported matplotlib, right? I've already imported matplotlib, so I don't have to import it again, right? So I'm going to be importing pandas for the analysis. I'm going to import Seaborn for the visualization, right? Print imported successfully. The reason why we're doing that is if you see this imported successfully, that means the libraries are imported without any error, right? So as we all know, we save our data set inside a variable called df. That's a convention, right? So df is equal to what? SNS. Because the data set is built into Seaborn, so SNS.load data set. So previously, we were loading the tips dataset inside the SNS, inside Seaborn, right? But this time, we're not loading the tips dataset, we are loading Titanic, right? And let's print the head. Normally, we print the head of our dataset to see that if our dataset is loaded correctly and to make sense out of our data, right? So df.head. Beautiful. And if you want to make it, if you want to beautify it, just print, just show it without using that print statement, just df.head. It's going to add some CSS to your output, right? So as you can see, let's make sense out of our data set. We have some key features. We have some columns. We have survived. That's survived means is the passenger alive. If you see 0, that means the passenger died. And then if you see 1, that means what? The passenger survived. 1 survived, 0 died, right? So, and we also have P class, right? P class means is either is the passenger in first class, is it VIP or second class or third class, right? And then the sex is self-explanatory. The age, that's the age of the passenger. And then we are not going to be focusing on these categories. We're going to be focusing on this fare. Fare actually is the ticket price, right? If you see for the first class is $71 and for the third class is $7, right? That's fare, that's the ticket price, literally the ticket price. And then we have embarked. Where is embarked? Embarked is the location, the port location where the user actually onboarded the ship. Is it on the S port or on the C port or SSSS, right? Like that's the bus stop. In our own understanding, that's the bus stop where the passenger boarded the bus or something like that. So for ship, where did the passenger embarked, right? Port of embarkation. That's basically it. So the next step is to perform what? Now we have our data. The next step is to clean our data, right? So how do we clean our data? Let's drop some irrelevant columns because I told you guys earlier that we're not going to be using these SIPs, patch, adult, embark town, alive, alone. No. Yeah, please, if I'm audible, go ahead and tell me in the comment section, please. So we're going to be performing some exploratory data analysis. So I'm going to be dropping some tables, some columns. Okay, thank you, Ishola. Thank you, Ishola. So I'm going to be dropping some columns. Please pay attention here. So df is equals to df.drop. Pandas is very cool, right? Just drop. I want to drop the columns that we're not going to be using. That's basically it. Then open your square bracket and write the names of the column that you don't want. So I'm not going to be working with deck. And then we're not going to be working with what? The embark town. And then we're not going to be working with either alive or not, because we'll be predicting that. And then we already have survived or not. So we are going to be working with the numerical value. We have who. We don't care with the who, right? Is it a man or a woman? We already have the sex. So I don't want to be working with the adult male. This is not going to be determining our prediction. And we're not going to be working with the class, right? Comma. And then there's what we call axis. Axis is equals to 1. So whenever you're dropping a column, right, the axis means if the axis is 0, that means you're dropping the columns, the entire columns. If the axis is 0, that means it's a row, you're dropping the rows. If the axis is 1, that means you're dropping the entire columns. 0 means row-wise operation. Axis 1 means column-wise operation. Please put that at the back of your mind. 0 means axis 0 means row-wise operation. You want to drop some rows. And then axis 1 means you want to drop some columns, column-wise operation. Beautiful. So let's go ahead. So now, if I click on Shift Enter, if I did not see any error, that means it has already dropped, right? So now if I say df.head again, you see it has already dropped the columns. Initially, we had the columns, adults, male, and the rest. So now it has already dropped them. Now you see the new data set that we have, right? With all the unnecessary columns dropped. Beautiful. Let's continue. So the next thing to do is to handle missing values. And I told you in our first class, I'm doing this because your project is around the corner. So consider this like a revision, right? So I want to fill the edges. Let's say, for example, some edges are missing, right? So how do you do that? How do you handle some missing values? Handle missing values, right? So dfh, select the h column, right? And then is equal to, right? dfh, that's a computed h, right? Dot what? Dot fill na. If you don't understand this fill na, please refer back to our first class on pandas. So df.fill na, it fills all the missing values, right? I want to fill it with the dfh. I want to get the h column, right? And I want to add the median h, dot median, right? dfh is equals to what? Get the dfh column, dot fill na. I want you to fill all the missing values with what? With the dfh dot median. That's basically it, and we are done, right? The second missing value that I want to handle is the embarked, right? The embarked. I want to handle the embarked. And I told you guys earlier that the embarked is the port of embarkation, right? So df embarked, right, is equals to what? Is equals to df, we just repeat the same thing. df embarked, right? Here, the reason why I'm working this is okay, let me just continue. Let me just I want to use the mod, right? If you take a look at this embarked, we have S class, C class. Okay, let's take a look at the classes that I pay the most, right? Let's just print df embarked and see which classes I pay the most, so that we use that to fill the missing values. df embarked, right? Dot mod. We all know mod now, the value that appears the most. So if you take a look at it, it's the S class that appears the most, right? No problem. So let's fill that with the mod, please. df embarked dot fill na, then df embarked, right, dot mod. We open our bracket and close it, right? And then we get the first one, since is 0, right? S is the first one, right? The reason why we're using the 0 is because we want to use the index to get this value, right? As simple as that. So I'm just going to go ahead and close my bracket. If we do not get any error, that means it's working, right? So what do we have to do next? Now we have already filled the edge with the what? With the median edges, and we have already filled the embarked with the point of invocation that appears the most. So the next thing to do is to convert this to a numerical value, right? If you take a look at this male, for the sex, we have male, female, which doesn't work well with what? With machine learning algorithms. This is what we call encoding. If you go to my GitHub, and inside feature engineering, right? I don't know maybe if that's available. Please go back to feature engineering, right? If you go to feature engineering, I believe this is what we call encoding. I don't know if that is available. Yeah, you can see scale data is, we are just transforming the data, right? We are just encoding this data. So if you take a look at this gender, very good. If you take a look at this gender is 0 for male and then 1 is for female, right? That is called a one-hot encoding, right? So if you take a look at this work class, state government 1, right? 0, 1, 1, 0. So we are just converting categorical values. Oh my goodness, I can't believe I did all that. That's one hell of a notebook. So please just go ahead and read how do you encode, please, right? So let me just go back to my data set so that I one-hot encode. I will map the male to 1 and I'm going to map the female to 0. So how do we do it? It's actually very simple. So df sex, right? df sex, get the sex column, is equal to what? df sex, right? df sex dot map. Let me just use map, because if I use the one-hot encoding that is built into scikit-learn, is going to confuse you. Let me just use the normal mapping too, so that you guys understand. Dot map. Okay, I want you to map the male, yeah, to 0, comma, and then I want you to map the female to what? I want you to map the female to 1, right? So the next thing I'm going to do is I want to map the embarked, because if you take a look at this embarked is we are using it to train the model. So we have to convert it to numerical values, because computers only understand numbers. Computers understand numbers. That's why we're converting them to numerical values. That's basically it. So df embarked, right, is equals to what? df embarked, let me be slow so that you guys should understand these things. df embarked, right, dot map, right? What do I want to map? I want to map the embarkation ports. So we have 3 classes. We have S class. I want to map the S class to what? To 0. I want to map the bus stop C embarkation port C to 1. And then I also want to map the Q port to what? To 2. So now we already have our distance. So if I run this thing and we don't have any error, that means there's no any error. So let me just go ahead and print this so that we see. Let's print our df.head again. Wow, that's amazing. So please pay attention to the data set now. You see, sex 0 means male. The sex is converted to a number. 0 is male and then 1 is female, right? And then if you take a look at the embarked, 0 is what? S, and 1 is what? C. And if we have other ones, if we have Q, it's definitely going to be 2. Let me print like 20 so that you can see the Q. I believe the Q is also updated as well. Yeah, if you see, whenever you see 2, that means it's the Q class. You can see 2 here. You can also see 2 here, right? So this is how you encode your data, right? So I believe this is a bit intermediate, or I should call it is a bit advanced. You already have my repo here so that you can go ahead and learn everything. If you read this, I believe you don't need any online reading. If you read this notebook, I guarantee you 100% that you will know everything pertaining in coding and everything, right? So let's go ahead and continue, please. Let's go ahead and continue. We have already, what did we do so far? Let's go back so that we don't forget things, please. We imported our Titanic dataset using the sns.load because it's already built in. We viewed the head to see what we are working with. We dropped some columns that we don't want. We printed the head to see the columns that we are working with. And then we fill some missing values. We fill the edge with the median edge. And then we fill the impact with the one that appears the most, which is the S class, right? And then we converted our data, our categories into numerical values so that the machine learning model will train. It cannot train with textual data, right? Even this ChatGPT even this language model that you see, it's actually converting your text into numbers. Computers do not understand text, they only understand numbers. So you have to convert whenever you say hello ChatGPT, it converts your hello to numbers before performing some transformer things on your text, right? So let's continue, please. So the next thing that I want to do is to visualize these things that I'm working with, right? So let me just go ahead and do that. SNS.barplot. SNS.barplot. The reason why I'm using SNS because we haven't used SNS to visualize data using barplot. So we've been using matplotlib for that. Let's use SNS for that. SNS.barplot. I want to x is equal to sex. On the x-axis, I want the sex. And on the, what do we call it? On the y-axis, I want survived. Sex column. And on the y-axis, I want the survived column. Let's see if there's any relationship between a passenger's age and their chances of survival, right? So survived, and then the data frame that I want to include is basically the DF now, right? And then plt.title, let me add a title to it, right? plt.title survival rate. Oh my God, survival rate by what? By gender, right? And then plt.show. That's amazing. So let's take a look at the survival rate. What does this say, please? I don't have to, let's see if you guys are good analysts. Please, I want you guys to interpret this in the comment section. Don't worry. David, go to my repo. You have everything that you need there. You have everything that you need there. Please interpret this data for me. On the y-axis, we have the survived, and on the x-axis, we have the sex. 0 is for female. Sorry, 0 is for male, 1 is for female. Please interpret this visualization for me. What does it say? What does it say? Who has the highest survival rate? Who has the highest survival rate? Okay, female, yeah. Who has the highest survival rate, please? Okay, somebody said female. 0 is for male and 1 is for female. Okay, okay, Abiola said female. Okay, I don't know what happened. Maybe the male were busy helping the females to survive. That's why all of them died. Maybe they were busy helping the females. Maybe that will explain things. Why are the females surviving more than the men? Yes, 20% male survive and 80% female survive. Yeah, Ishola. Yes, based on, yeah, 70 something, it's not up to 80, it's almost 75 or 74%. And if you take a look at, it's almost 19% male survived. What happened? I don't know, maybe they're busy helping the females or something like that. Right? So now we know the survival rate, right? We know what we're working with. We know that almost 20% of the male survived, and then almost 80% of the female survived, right? So that gives you an insight on your data that almost all the men died, right? Almost all the men died. Okay, Ishola, you're right. So let's continue, please. I'm curious. I want to see survival rate by passenger class. Let's see if the VIP people survived more or not, right? So it's actually very simple. SNS.bar plot. Let me just write it again so that you guys see. And on the x-axis, I want the P class, which is the passenger class. And then on the y-axis, I want the survived column. Survived. And then the data set that I want to is the data is DF, right? Data is DF. So plt.title is going to be what? Survival rate by class, right? Survival rate by class. And then what again? plt.what.show. plt.show, right? So let's go ahead and check sns.barplot x-axis. So if you take a look at what is happening here, I already told you guys earlier that that if the class is 1, right? If the class is 1, or if first class, that means first class. If the class is 2, second class, and if the class is 3, that means it's third class. So please, I want you guys to guess, based on this data, which class survived the most? Which class survived the most, please? Based on this data that we are having, I want you guys to explain to me which class survived the most, please. I want you guys to go ahead and storm the chat section. Let it be very interactive, please. Let it be very interactive, please. Which class survived the most? Which class survived the most? Yeah, the first class. Very good, the first class. Very good, the first class. So if you take a look at this, it says maybe the first class, maybe they have more life jackets. I don't know, maybe I've watched the Titanic movie like 20 years ago. I've forgotten almost everything. Yeah, I believe maybe it's because they had more life jacket and more assistance or something like that. I don't know if people that watch the Titanic movie will relate, right? So I'm so curious, right? I'm so curious. Let's say we want to, okay, Jackson, you're right. Olutola, you're right, first class survived much. Okay, the next thing that we want to see is we want to see the age distribution of the passengers on that ship, right? So I want to use histogram, or I should have asked you guys, whenever you want to visualize distribution of things, right? You use what? You use histogram to do that. So SNS.what? SNS.histoplot, right? DFH, as simple as that, right? And then the KDE is going to be true, right? So KDE, I just want to add the line, right? The trend line to it. So plt.title, the title that I want is going to be age distribution, right? That's the class that's the title that I want. And then I'm just going to use plt.show, right? So this is going to plot okay, histoplot. It should be hist, not histoplot, sorry. Histplot. Wow, beautiful. If you take a look at Seaborn's visualization, it's actually more beautiful than Matplotlib's visualization, because Seaborn is actually built on top of Matplotlib, right? They have added some enhancements, right? So if you take a look at this, distribution, most passengers are between between 20, because that's where the chart started spiking up, at between 20 to what? 20 to 40, right? And the highest group of age is what? 30. We almost have almost 250 passengers that are within the 30-year group, right? So now we know that inside the Titanic ship, the age range, most of the age range is between 20 to 40 years old. So you see, now we're performing some exploratory data analysis, and we're performing some visualization. Please, you guys should take note, right? So now we've already We know many things about our data now, right? We have many insights about our data now, right? We know the survival rate by gender, right? We know the survival rate by class. We know the age distribution. We know either male or female survived, right? We know all these things, right? So now, since we already know a lot of things about our data, now what we want to do is we want to build a machine learning model, a logistic regression model to perform our classification, right? We want to see, we want to predict either a passenger has survived or not based on the data the model has never seen before, right? So how do we do that? There's what we call feature selection, like we did in our last class, where we selected some features of houses, right? So the features that we're going to be using is for this data is let me just go ahead and change this to a markdown. Let me just change this to a markdown. It's going to be building the model, right? Actually, building the model is very simple. It's not going to take much of our time. So the features that I want to select is just select the features that are relevant to your data. This is going to make the accuracy of the machine learning very, very high, right? So I want to select, and I told you guys in our last class that whenever you're selecting a feature, please use double square bracket. Use double square bracket, make it a two-dimensional array. So I want to select the passenger class. I want to select the sex. I want to select the age, right? I want to select the what? The fee, that's the price, right? I want to select the SIPs as well, right? We also have we also have the purge. What do we have again? We also have what? Embarked. And then what are we going to, the Y is what? The small y is what? What we are predicting. We want to predict either the passenger survived or died, right? Survived, right? So now we already have our features. We already have our features now. So key error, we have some key errors. Let's go and check. SIPs, okay. SIPs is not there. Okay, it's SIBSP. SIBSP. I think SIBSP. We forgot to spell that correctly. SIBSP, right? So now we are not having any error, right? So the next thing to do is to split our data into what? Training and testing. Please pay attention to this part of the analysis. Splitting our data, what? Splitting our data into what? Into training and what? Into training and testing. So in our last class, we've done that already. So we are going to import the function to do that. So from sklearn dot what? Model selection. What are we importing? We import train underscore test underscore what? Split, right? And then xtrain, we create a variable to save the training data, xtrain, comma, xtest, comma, ytrain, comma, y underscore test is equals to what? Let's call the function that we just imported, train underscore test underscore what? Split, right? Inside the train test split, we want to pass what? We want to pass our x, we want to pass our y, right? Our x is the feature, our y is the value that we want to predict, and then the test size is going to be, I told you in our last class that the test size is the size that you want for the percentage of the data that you want for training and for testing. So for the test size, we want to use 20% of the data for testing the accuracy of the model. And then we want to use the 80% to train the model. We want to use 80% to teach the machine learning algorithm. And then we want to use the 20% of the data to test the accuracy of the learning, right? So random state, the random state of the model should be what? Should be 42. Right? So let me go ahead and run this. Now I've already splitted my data. So if I go ahead and print my xtrain, you see, now we have the 20% of the data in our xtrain, right? So if I go ahead and print my xtest, right? You see, now we have the 80% of the 20% of the data for testing. As you can see, it only has 179 rows, right? Okay, let's see the trend. You see, it has 712 rows. Please, I know by now you know what we're doing, right? So let's see the Y trend. Let's see the Y trend. Y underscore trend. You see, we have the Y trend. The Y is the survived or not survived. It's a numerical value. 0 for what? Survived, and 1 for not survived. As simple as that, right? So what do we do now? Let's see the Y test. You see, we have the Y test as well, which is 179 rows for the testing. So since we have our data for training and we have our data for testing, what do we do now? What do we do next? We build the machine learning model, right? Let's build the machine learning model. Let's do the fun part. Let's build the model. Let me comment this out. Build the model, right? Let me convert this to a markdown. Beautiful. Let's build the model. So how do you build the model? So let's import the model, right? Let's import the logistic regression model. So from sklearn dot linear underscore model, right? We import what? We import logistic regression. In our last class, we imported what? Linear regression. Logistic regression, right? Very good. So what do we do next? Now we import what? We save the model to a variable. Model is equals to what? We instantiate the model. We instantiate the logistic regression class. How do we do that? Model is equals to logistic regression, right? So now we have access to this model inside this variable, right? Right? So the next thing is simple. We train the model. How do we train it? Model.fit. Model.fit. Right? It accepts some parameters. Right? It accepts some parameters. What are the parameters that this model accept? It accepts your training data. And our training data is what? Is the X-train. X-train. What is X-train? X-train is are the features. Are the features, right? What are our features? Is like the class of the passenger, the sex, the age, right? The embarked and the rest. And then we have our Y train. What is our Y train? Y train is the value that we want to predict, right? Y train. So let's pass it. Y train, right? We have our X train and we have our what? We have our Y train. So if I go ahead and press Shift Enter, this is going to train the model. So the model is training now, but we're having some errors now. Okay, let's go ahead and see the errors. Why are we having these errors? Total number of iterations, reach limit. Okay, it has reached the total number of iterations. Okay, let's go ahead and fix that. Why are we having this error? The total number of iteration means how many times the model is going to learn, right? How many times is the model going to, I believe they have updated. They have updated the library, that's why. So let's go ahead and just fix that. Let's just go ahead and fix that. I'm just gonna go ahead and add here. What is this? Comma. I'm just gonna add the max, I believe is max ITA. Max ITA is, I want it to train 1,000 times, and I want, let me just go ahead and select the learning method, which is the solver, right? The solver is just the learning method now. What type of learning do I want? So we have many types of learning. If you want to see how many types of learning do we have for logistic regression, just go to the scikit-learn library and scikit-learn documentation, and I believe it's there. So the solver that I want to use is going to be what do we even call it? It's leap linear, something like that. I don't know, maybe if this spelling is correct, but let's just run that and see. Okay, we're having an error. Sorry, it shouldn't be here. I believe this parameter should be inside the class, not inside the model.fit. We made a mistake. So let me just go ahead and Control X this, Control X, and then go back to the model logistic regression class. And then I'm going to Control V this, right? And then I'm going to delete the first comma. Beautiful. You see, the error is gone now. Now the error is gone. So let me explain this to you guys. So the max IGTA is the number of times that the model is going to train, right? We want the model to train 1,000 times. It's self-explanatory. Now, if I want you guys to be good in something, if you train 10 times, yeah, you're going to be good, but not that good. If you train 100 times, you're better. But what if you train 1,000 times? What if you train 1,000 times? You're going to be a professional, right? So that's the meaning of the max IGTA. And then the solver is what type of solver do we want to select for the learning process? So we are using the leap linear solver. We have like 4 types of solvers, right? So now the model has already trained and we have access to it, right? We have access to the model. It has already trained. So let's check the accuracy of the model, right? Let's check the accuracy of the model. Let's see the accuracy of the model. So I'm going to import some libraries from sklearn.metrics, just like we did in our last class. Import accuracy score, right? So let's use the prediction values to test the accuracy. Y prediction, which is the prediction, is equals to model.predict. Let's make some predictions and see. And we are using the X test. I told you that you use the X train for training, and then you use the X test for making predictions, right? So I'm going to be using the X test for prediction. So after that, I'll print the accuracy for you guys to see. Print accuracy, right? I'm just writing the text here. It doesn't matter. You can write anything that you want. So I want to call the accuracy score function, right? And then I will pass the Y test to it, Y test, and then I'll compare that against against the Y prediction. This is self-explanatory, right? So let me just go ahead and print. I'm having an error. Okay, why is it? Okay, I did not close the bracket. I don't even have to read the error. Okay, I'm still having an error. I'm still having an error. Model.predict should be O. Model.predict. Oh, sorry, that's a mistake again. Model.predict. Wow, we're having 80% accuracy, right? We're having 80% accuracy. That's totally acceptable. That's totally acceptable. So our model was able to predict 80% accuracy, right? In an unseen data, right? For example, if you take a look at this accuracy score, we are just passing the Y test. We're just telling the accuracy score that, hey, here is the Y test, here is the actual answer, here is the actual answer, and Y prediction, this is the predicted. You see, Y prediction, we just make some prediction. We want you to compare the actual answer versus the answer that the model was able to predict, which is what? The Y prediction. Compare it and the model score 80 over 100, which is acceptable, right? Which is acceptable. If we like, we can go crazy. We can go crazy. We can add some more features. We can add some features to it, right? If we like, if you like, you can have maybe some 90%, something like that. But 80% is crazy, actually, honestly. You can maybe add more classes to it so that you give the model some more patterns to learn from. Like, for example, you can give some features. Is the passenger alone, right? Is the passenger alone? Or maybe something like, is it, okay, man or woman does not matter. Okay, is the passenger actually an adult or adult male or something like that, right? If you give the model some features, more features, maybe it's even going to skyrocket this accuracy to even 100. Sorry, 100 is not realistic. It's to maybe 85 or 90, something like that. But 80 is, we can work with 80, like, right? With 80% accuracy is actually in the A class, right? So this is what we call, I want to teach you guys something, actually. I'm going to teach you guys how to actually visualize this accuracy. That's what we call a confusion matrix. A confusion matrix is a metric that actually helps us to see the accuracy of our model, right? How many times has the model been wrong? So how do we do that? How do we do that? Let me just go ahead and import some libraries to that. Let me import some libraries for that. Let me just go ahead and use a markdown. Confusion. Please, if you want, you can Google confusion metrics. Maybe search Wikipedia or something like that. Confusion metrics. Let me convert it to a markdown. I never thought that we were going to get 80%, honestly speaking. In the first try, I never thought that. So from scikit-learn, from sklearn dot metrics, we're going to be importing what? We're going to be importing confusion underscore metrics, right? So please pay attention. This confusion matrix is going to confuse you, right? A bit if you don't pay attention. So I'm going to define a variable called confusion matrix, which is CM is equals to what? I'll just call this function right here that I just imported, right? I'll just call this function confusion matrix. Hey, confusion matrix, come here. I want you to check the Y test, which is the actual answer versus the Y prediction, versus the answer that my model predicted, right? So now confusion matrix has some answers for us, right? So let's visualize that answer and see. So I want to use Cbond, which is sns.heatmap. I want to use a heat map to visualize. I want to pass the confusion matrix to the heat map, and then I want the annotation, which is annotate. I want to have some annotation, which is true, and then I want the FMT, right, to be D, right? Don't worry, you're going to see that in a minute. I want to add some X label to it. X label should be the predicted value. And then on the Y-axis, I want the actual value. PLT dot Y label is going to be the actual value. And then I just want to use PLT dot show as quickly as possible. Beautiful. So now we have our confusion matrix. So how do you make sense out of this confusion matrix? So this is what we call true positives and false negative, right? True positive are the values that are correctly predicted survivors, and false negative is when the model predicted that the passenger died, but the passenger actually survived, right? True positive means it has correctly predicted that the passenger survived. And then false negative means the passenger actually survived, but the model predicted that the passenger actually died, right? So if you take a look at this confusion matrix, it's a heat map, right? So on the left side, you see that we have actual on the y-axis, and on x-axis, we say that we have predicted. So it's actually very simple. I told you in our visualization class when we did the heat map is for the 0, our model actually predicted that the passenger survived, right? Sorry, actually the passenger survived. I don't know which class did we use. Did we use 0 for survive or 1 for died? I don't know. Yeah, so 0, actually the passenger survived, right? And then 1 means the passenger actually died. So you can see that 90 times our model was able to predict correctly that the passenger actually survived, and then 20 sorry, I had issues with my network again. Let me just go ahead and share my screen as quickly as possible. We're about to round up for the time. We are doing a little bit of advanced stuff here. Sorry for the time. We're about to round up, please. We're about to round up. So 90 times, I don't know if my mic is audible, please. Is my mic audible? So 0 means survived, and then 1 means the passenger died, right? So our model is able to predict 90 times that the passenger actually died, and then we have some false negative. Sorry, we have some false positives. So if you take a look at the predicted, the model made a mistake 20 times. It says 90 times survived, and then 20 times the model predicted that the passenger survived, but actually the passenger died, right? And if you take a look at the died, our model was able to predict that 54 times that the passenger actually died, but the model said 20 times that the passenger actually survived, right? 90 times the passenger survived, but 15 times the model made a mistake that the passenger actually died, but it said the passenger survived, right? And then 54 times the passenger actually died. Sorry, the passenger actually survived, but 20 times the model said that the passenger actually died. So if you take a look at this model, it's able to accurately predict surviving passengers, right? It is actually very good in predicting whether a passenger survived, but it's a bit weak when predicting if a passenger actually died. By me looking at this confusion matrix, because 90 times passenger actually survived, only 15 times the model was wrong. But when it comes to the died, it's actually able to 54 times correct, but 20 times, 20% is actually wrong, right? That's why we're having 80% accuracy. So if you like, you can bump this up. You can bump this up. You can add more features to it. But you can do some feature engineering, right? But this is too advanced for you guys, honestly speaking. You can do some feature engineering whereby, like, for example, I believe many years ago, there was a time, I believe, when I got some 90-something% accuracy. I believe if you create something like family size, right? For example, we have SIPs and we have patch in the Titanic dataset, right? So for example, if you create another column like family size, which is equal to the SIPs plus the patch, and this is what we call regularization in machine learning. If you add some regularization where you add a penalty of maybe L1 or L2 to the model, right? It's going to increase, or if you use gradient descent or XG boost, it's going to bump the accuracy up, right? So, but this is a bit advanced. 80% is very good for intermediates, right? It's very, very good, 80%. So I believe by now we have come to the end of our linear regression class. So, and please, honestly speaking, there's a multi-class linear regression. If you take a look at the whiteboard, we only covered the first one, right? Where we were able to do a binary classification, right? Though it's actually very simple. If you can do a single class, binary classification. So I challenge you guys. You have the internet, you can go ahead and research. So you have binary classification, a very well-documented notebook. If you like, I can share this with you guys, right? So I want you guys to go ahead and add, maybe do a multi-class classification on your own. I want you guys to use the iris dataset. This way we call the iris dataset, which is built into, I believe it's built into scikit-learn or Seaborn, in between the two, right? I believe it's built into scikit-learn or Seaborn. So please, I want you guys to go and import the iris dataset and perform a multi-class, because I believe it has maybe I believe it's 3 classes. Yeah, I believe it has 3 classes. So please go ahead and load the iris dataset into your notebook. I believe it has Setosa, Versicolor, and Virginica or something like that. I forgot. It has 3. I believe it has 3 classes. So import the dataset into your. Let me just Google it so that we can see. I forgot all these things, honestly. Iris dataset. Yeah, we have the Setosa, we have the is it versicolor, and we have the virginica, right? As you can see, it has the petals and sepals. So the machine learning, yeah, we even have a Wikipedia page on that, right? So the machine learning model actually learns maybe from the length of the sepals, right? Based on that, it's able to classify the 3 categories of the flowers, right? You see, it's a multivariate data set used and made famous by the British statistician and biologist, right? Ronald Fisher. So please go ahead and just familiarize yourself with this. Go ahead and familiarize yourself. Please do not use maybe ChatGPT to browse about this iris, because Wikipedia gives you more detail. Honestly speaking, as you can see, we even have the scatter plot here, which is something that maybe all these language models will not give you, right? We even have use of the data set here. It's very comprehensive. We even have pictures and everything. You can come here, you can change the appearances, you can change the width, the color, everything. Wikipedia is so amazing. As you can see, we even have a simple R code, though it's not Python, it's R, that is used to actually, yeah, we also have Python implementation. Yeah, it's inside scikit-learn. From scikit-learn.dataset import iris, right? As you can see, we have a little code whereby we're importing the iris dataset, and then we are categorizing them, right? As simple as that. So I want you guys to go and import the iris dataset. As you can see, we already have the code to import your dataset here, and then I want you guys to classify the 3 classes. Please use multi-class logistic regression to do that. So that in our next class, if you're having any issues, I'm going to help you with that, and then we can go into random forest. So we have already consumed too much of your time. Honestly speaking, it has been very interesting showing you guys some classifications. So I'm going to be, yeah, no, see, Juliana, you don't have to, yeah, Olumuyiwa, the test done was to detect the accuracy. Can we use, see, Olumuyiwa, pay attention. We've already built the model and we have already tested. We have already made some predictions. Just take a look at it. See, Y prediction is equals to model.predict X test. If you take a look at this, we have already used the model to make predictions, right? Y prediction, we created a variable called Y prediction, and we call model.predict X test. We are just passing the X test. See, let me print the X test. You see, this is the data that we are passing into this is the data that we are passing. If you take a look at this data, we don't have the survived column, right? So based on this data, if you give the model this data, it is going to predict whether the passenger survived or not, right? So if I go and say model prediction is equals to model.predict, right? X test, right? This X test, right? Our testing data, and I'm going to pass our testing data to it, X underscore test, right? So if I go ahead and print this prediction, you see, we have an array, right? And if you take a look at the Sigmoid function, what does it say? 0 means no, did not survive, and then 1 means yes, right? So it is able to predict 0, did not survive, did not survive, did not survive, right? Survived, 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 did not survive, survived. And it does this prediction for the entire testing set, right? We have for the 176, is it 179? Yeah, 179 data set. It has been able to make 179 predictions in 1 second, right? So we have already used our model to make predictions. Please don't confuse yourselves. So please, do you have any question? If you don't have any question, then we can call it a day. Please just go ahead and practice. Machine learning is so amazing, it's so powerful, it's very, very powerful, right? And if you pay close attention to it, if you practice it, it's actually, honestly speaking, it's going to be so easy because all the mathematics has already been done for you guys, right? All the mathematics has already been taken care of in the library. So you just have to practice, practice, and practice. So please, do you have any question? And there's also, let me answer the second question. Juliana, the Titanic dataset is actually built into, Seaborn. Let me just, let me scroll up so that I show you guys. If you take a look at this, we use Seaborn.load dataset Titanic. If you're paying attention towards the tips dataset, if you say tips, it's going to bring the tips dataset, right? So Titanic, most of these datasets are regular, they are very popular. So that's why they are built into all these libraries. So, and if you take a look at the IRIS datasets, it's already built into Seaborn as well. So sorry, scikit-learn. From sklearn.dataset, import load IRIS. So let me just copy this code to prove to you guys that is actually readily available. So if I put it here, right, load iris. So, and then what again? It says iris is equal to load iris. We're just instantiating the dataset class, right? So iris is equals to what? We just call load. We just call the name. Yeah, we just call this thing. So Control V, and then we instantiate it using a bracket, right? So if I say iris.head, something like that, it's going to show the data sets, I believe. Yeah, we're having an error. Let's check the error. Okay, head. Okay. Well, we have been head. Yeah, I believe it should work. Iris.head. Okay, let me just go ahead and say iris. Or honestly speaking, maybe it's because, let me check, maybe because the columns are not named, something like that. But here, we see that there is iris.head. Well, maybe they have updated. Maybe this Wikipedia articles is maybe old or something like that. But let me just copy paste everything to see where we're having. Yeah, iris.head is maybe it's duplicated. They remove the column names, because whenever you say .head, it used the column names to put the columns, right? Iris.info is not available, right? So because it has no columns, so I believe you can just say iris. If you take a look at the data set, we don't have column names, right? We just have the class. Yeah, how many data do we have? Let me check. Let's check. And we have feature names. The feature names, we have sepal length in centimeters. All right. Let me see. Yeah. Feature names. How many data do we have? Yeah, you can see that we have some feature names. We have sepal length in centimeter. We have sepal width in centimeter. We have the petals length, and then we have what? We have the petals width. So these are the features that you're going to load into your data sets. In our case, using the Titanic, these are the features that we pass into the X, right? So you see, these are the features that I want you to add to the X part of your model. And then for the Y part, you have these values, right? The petal length, the petal width, and everything. So I want you guys to use this data set to perform multi-class classification. You see, we even have description of the data set, right? Which is a well-documented data set, right? So I want you guys to use this to make predictions, please. So let me see if I can be able to, if we have a target, let me see if I have iris.target, something like that. Yeah, we have iris.target. So here are your targets. Here are the predictions that I want you guys to make, right? Here are the predictions. These are the targets. So these targets should be on your Y, please, on your Y. This should be on your Y, because these are the targets that you want to predict. You want to predict either a 0, maybe for Setosa, right? 0, 1, 2. You have 3 classes. And then for your X, let me see if I can be able to help you guys a little bit. Let me see if I can create a data frame on that. X is equals to, let me convert it to a data frame, pd.data frame, and then iris.data. And then for the columns, we have seen earlier on that the columns are available inside feature names, right? So the columns should be what? Iris dot what? Dot feature names, right? So now if I, yeah, okay, PD
names.
Dot, no, we are missing the dot, PD dot data frame. Okay, feature name, feature.
Names.
Okay, feature. I believe there's an error here. Iris dot feature names, right? Okay, there's an S, feature names. Yeah. So beautiful. Okay, so now if you go ahead and print X, we can see that, wow, now we have the data, it has been converted into a data frame. So we see that we have the sepal length, the sepal width, the petals, right? And if we print the target, which is Y, as you can see, we have the target. So your problem is even 90% solved now. I've already solved your problem like 90%, right? Because right now I can, if I like, without even scaling, I can just call my regression model, my logistic regression, and pass this, split this data into training and testing. You already have the data, right? If you like, you can go ahead and split this data into training and testing, right? And then start making your predictions, right? So this brings us to the end of this class. Honestly speaking, it's getting late. If you guys have any question, just maybe save it in our next class. I'm gonna be, yeah, feature names, Ishola. Thank you for that. Is feature synonymous to header in Excel? See, Ishola, don't get confused. The feature in machine learning means it's like you're teaching the machine, you're teaching the algorithm that, hey, these are the features that I want you to learn, right? Based on these features, I want you to predict the target for me. In our house price prediction, we give the machine learning some features like the size of the house, the location of the house, like the number of bedrooms, and then we give it the price. We show it some sample price. Hey, if you see that a house is maybe one plot and then it's in GRA and it has like 5 bedrooms, it should cost 10 million, right? So we show some samples to the machine learning model, and then if you give it a new feature like the location of your house and the size, it is going to predict the price, right? So these are the features we are talking about. So in your case, you're saying is feature synonymous to header in Excel? No, the column name in Pandas is synonymous to header in Excel. Column names. For example, in this case, we have some what? We have some sepal length, sepal width, and petals. These are the columns. So they are synonymous to what? Headers in Excel. As simple as that. So please, okay, the video link to create the GitHub account, there's no any video link, Juliana. It's available in this video, right? It's available in this video. It's available in this video. So just go ahead and see. If you can Google, open a GitHub account, right? If you Google this, it's going to show what? Sign up to GitHub. Sign up to GitHub, right? But I'm already logged in. It's not going to show me the sign up page. Why? Because I have already logged into my account and it has saved the login process, right? But in your case, you've never signed. Oh, let me see if I can open an incognito window or something like that. In your case, it's actually going to show you sign in. Let me see if this private window, github.com. Yes, I have opened a private window. You see, sign up for GitHub. You just enter your email, right? You just enter your email here, right? And then sign up. So this is going to ask you for your what? For your password, for the username that you want. You see, the email you provided is already associated with an account, right? But in your case, it's not going to show that error. So the password that you want, the username, your country, right? You want to receive occasional product email, and then you click on continue, right? Maybe with some, maybe I don't know, maybe they have updated the signing process, because I've done mine for like 7 years ago, 8 years ago. So maybe they have updated, maybe they say two-factor authentication or something like that, whereby they verify your email or something like that. So after that, then it takes literally like 5 minutes to do that. So it's very simple actually. You don't need any video for that. So please, I believe we should just call it a night because it's getting late. Honestly speaking, it's getting late. It has been very interesting class. So please, I want you guys to practice. Practice makes permanent. Practice makes permanent. Please, we're about to start our project. Yeah, we're about to start our project, please. So I want you guys to practice a lot, right? I want you guys to practice a lot, please, so that we can start focusing on our capstone project, because next we are going to be covering some K-means cluster, which is another advanced machine learning algorithm. Then after that, we are going to see how we can use Python to play around with Excel. Then after that, we'll start focusing on your capstone project. We'll be answering some questions. We're not going to be having classes anymore. We're going to be addressing your question and we'll be discussing your project. Sorry, after that, we'll be doing some dashboard. We're going back to Excel. I'll teach you guys how to build amazing dashboard, right? Some amazing reports, how to design reports and dashboards. Then after that, we'll start discussing on your projects, right? So please go ahead and open your account because we'll be using your GitHub account to validate your project, and that is going to validate your certificate, something like that. So I'm going to be handing the class over to the host because I believe by now we have almost covered almost everything that we're supposed to do today. Yeah.
Yeah, thank you, MK, for the excellent session. It's amazing that you are laying emphasis to growth, individual growth for the students, and I want to encourage you all once more to go ahead to ensure you create a GitHub account, as you cannot underestimate its importance, especially as the global community is concerned, because
Yes, very, very important.
yeah, that is where you can showcase your expertise in the tech industry, especially when it has to do with coding language. And you can also be able to learn fast from other people's works. You can copy other people's work, and in the process of the what they call fork is like you redoing, learning the process of what someone else has done, and then you try to get your hands better. So, like I stated to you guys earlier in your platform, learning is not effective when it is dependent on the trainer above 50%. Learning is 25% dependent on effective learning, is 25% dependent on the trainer, 75% independent by the student. If you are not committing 75% of your time for the training on your own, either through research, then you are not building the best foundation for yourself. Your trainer is doing an excellent job, but sometimes going outside your comfort zone is what will pay you off in terms of value-added initiatives. Also, another thing I want to remind you all is don't design a habit of always wanting to watch what was done in class. Learn independence. If not, tomorrow you will go somewhere and you will get a job, or you will be in an interview room, and all that. Dependence kills. If you learn under a structure where you think it is only when videos are made available that you will learn, then you are not learning. If you learn under a system where you want to watch a single thing 10 times or 5 times before you think you get it, then you are not learning. Learning is when you are able to do those tasks on your own. And on your own is enough when you plan appropriately. So once more, please, when you guys create your GitHub account, try to see how you create your repositories. And there is always a start. Even if you just heard the word GitHub and you create just the account without using it, someday, like I heard one of you guys mention today, that was somebody who was part of the cybersecurity class. Maybe it was mentioned, he didn't care to create, but the second time he heard it again, it made more sense. So that is how knowledge is. It's not a do or die affair. Even if you have not mastered all that have been done, gradually follow on the process. Still come to classes. You might not have captured the initials or the middle or where we are. Still follow up with subsequent classes. And then you might not get something, but just be part of it. It's still part of the learning curve. Remember, it is learning curve. I've not seen anywhere they say it is learning straight line graph. I've not seen it anywhere in the world. Or if somebody has seen a learning process where the trainer gives you 100%, you receive it 100% and you give it back to him 100%. I've not seen it anywhere. That is why the standard is a learning curve. It will always be a curve. That is why there will be rooms for failures. There will be rooms for complete ignorance where you will see yourself like you are in the cloud. Don't take it as if, in short, those who give up are actually those who were not even designed to be part of the program. So those who are still part of this program up to this time, I say kudos to you all. Keep it up and keep doing best. But take note that at the end of the program, if we are going to be issuing certifications, then it will be based on merit, not based on presence. So I encourage you all. Merit you might showcase some level of passion. We can give you certificate of passionate studies or passionate participation, but to showcase excellence is key, so that you don't just have certificates for namesake, but you have them to be able to attest to the fact that you actually know what you are doing. So MK, continue the good work. We will meet again on Wednesday. The video session will be available for you guys. So
All right, thank you very much.
Yeah, till 48 hours. Even though the other one is still available, the other ones are still available.
Yes.
Yeah, but it's a privilege if they are available above the stipulated time. So good night to you all.
All right, good night. Yeah, have a good night as well.
Thank you, MK.
All right.